All right, so we're starting here, and at this point on the graph, the x value is 3. So I'm going to start by plotting, and you see you've got a little bit nicer grids here this morning. Let's start with a scale. I need my x values to go up and down to positive and negative 3, so that the graph never gets wider or farther left than negative 3, and it never gets farther to the right than positive 3. So I can afford to use most of my graph to go to 3 and negative 3. At the same time, y only goes up and down to 2. So if I use the same scale here, then 2 is as far as I need to get for y. And it's not strictly speaking necessary to have the same scale on both graphs, but personally, I find it a little bit helpful as I'm working through one problem if the scale on both graphs is the same. Okay, so if x is 3 here, I'll start way up here at 3. And in my book, what that says is, oh, this is probably going to be a cosine graph because cosines start high, right? Whereas sines start at 0. So this is probably going to be a cosine graph. So x is 3. And then the next time I hit a maximum value for x or a minimum value for x, it's all the way down here at negative 2. So maybe about here. And then if I keep going, I get up to x equals positive 1. Down to x equals negative 3. So I'm all the way down to basically the bottom, or as low as it's going to get. And then up to positive 2. Down to negative 1. And up to positive 3. Did I catch everything there? I think you're actually hearing me wonder aloud through this. So I'm not entirely sure whether I captured everything. So I'm just going to run back through the graph. I went 3, negative 2, 1, negative 3, positive 2, and I'm looking over at my iPad as I do this, negative 1, and positive 3. So it does look like I captured everything just between here and here. So this would be my 2 pi. Right here, which means that ideally I'll get from 0 to 2 pi for y when I do that in about the same amount of space, ideally. It doesn't really matter if you don't, but okay, so now that I've got that, again, if I think about the sort of the white space, you can sort of see that starting to look a bit like a cosine graph, right? It comes down and goes back up again. But we're not just filling in the white space. We need to know more about the graph than just the red graph, the smooth graph that comes through here eventually. We need to know more about it than that. So I'm going to go ahead and connect the dots. That's not the prettiest graph I've ever drawn, but I think it does the job. And then I'm going to go back in, take my highs and my lows and try to find the midpoints. So maybe there and there. I don't know if you've noticed, but I tend to leave that last one to the very end, the 2 end midpoints, because I need to be careful and think quite carefully about, in this particular case, does this graph go up farther or does it start to come back down again? And in this case, the graph here would have come up from below. If I had another cycle on here, you can see it would have come up from below. And if I add another cycle, then the cycle that I add will start in the same way as the previous cycle started, and it would come down. Okay. So you don't necessarily need those dotted lines, but you do need to think about what's my graph doing on the ends there. Because in this case, what this means is that my midpoint is between this low and this high. So it's about there. Maybe about there. So now when I connect these, I get something kind of like this. Okay, and that looks an awful lot to me like a cosine graph. Okay, there's only one cycle of cosine, so I've just put cosine of t. And ultimately, I'm going to have, let me move this over a little bit. I'm going to have that plus something else, right? Plus something else. So let's talk now about the amplitude of this graph. The amplitude of the cosine graph is kind of looks like, I mean, it's not, if that's 3, then 2 is maybe there. I would say the amplitude is probably just 1, right? So let's just call that 1. And you don't need the 1 in front, but the fact that I've put it there helps me remember that I've dealt with that particular amplitude. Okay, now let's see, what have I added to my red graph to get to my blue graph? Or what do I need to add to, let's see, there's a nice kind of minimum there. What did I need to add to this red graph to get the actual graph? So the equation that I'm looking for is this red graph plus something, right? That gives me the equation of the blue graph. It's the smooth graph plus the other stuff that I've added to it. So what have I added to this red graph? Well, if I go right back to the beginning and see that, first of all, I've clearly added something right from the very beginning. And then what that looks like is, to me, is a cosine graph, right? So if I start right at the very beginning and see kind of what have I put on top of the red graph, I get a cosine graph. Let's scooch this over a little bit. Okay. So, and then I have 2 questions I need to ask myself. One is, what is the amplitude of that graph? And the amplitude of this cosine graph here, this one that's on top. And that has to be 2, right? Because if this is where I'm starting, that's kind of my x-axis now. And what I've added to it brings me up to 3. And this one had an amplitude of 1. Then what I've added must be 2. So that cosine graph there has an amplitude of 2. And then the next question, of course, is how many copies of this do I have? There's 1, there's a second one, and there's a third one. So I have that for my x of t graph. Okay, so far so good. Any questions? And hearing none, I think I shall just continue. Once I could type this in now. I could go up into my answer box and type this in. And some people do that just so they've kind of got a record of it and they know that part's done. But I won't be able to get an overlay graph or red graph until I have both of my equations. So I'm going to go ahead and do the y equation next. Okay. All right, so let's see here. I'm going to go back to blue. And I'm going to say that my y of t equation is, and then I have to look at what y is doing as I travel around the graph. So I'm going to go back and forth again between the iPad and the screen with the graph on it. Again, I'm starting at this point here because that's where I started for my x graph. Okay. At this point, the y value is -1. So I'll go ahead and plot point -1. And really what I'm saying here is this is where t equals 0. This is where I'm starting. If you want to think about it as an ant traveling along this path, the ant starts at time 0 at this point right here. And at this point right here, that's at this point in time, the y value of the position is -1. So t equals 0 associated with those coordinates. Okay, and then if I travel the graph, go along the graph, y gets to a maximum right about here. And in this case, I'm going to go ahead and call this 1, even though it's really closer to a half. And we can tweak the graph, or we can tweak the equations later on if we need to. I feel safe in doing that because everywhere that there is a maximum along, here's another one here, they're all at sort of the same height. Same thing down here. The minimums are all at about -1/2. So I'm just going to go ahead and call those 1 for now, just because it's easier to think about. It's easier to think about in integers and so on. So I started at y equals -1. I'm coming up to +1. Continuing along the graph, I come back down to -1 again. And then I come all the way up to 2. After that, I come down to -1, up to +1, down to -2, and then up to -1 where I started. Okay, and I didn't quite make my 2 pi there, but that's okay. I got a feel for one cycle of the graph. It's not an exact science. We're just trying to get a feel for what the graphs are doing. Okay, so let's connect those. Note that I started here and went up here first, and then I'll do that part again. There's an awful lot more going on with this graph than there was with the X graph, right? I don't know, maybe about the same. Okay, so there's my initial graph for y of t. I'll go back and put in the midpoints. And again, I'm kind of starting not on the ones that are right on the end, but on the ones in the middle. And then I'm going to go back and think about what would happen if I started another cycle here. Would my graph go down? Is this a midpoint here? In this case, another cycle would keep going up. Okay, and in fact, it would go up to about here. So I have a midpoint about, let's see, about here, I guess. And the same thing over here. If I had started earlier, then my graph would have gone down to -2. So I have a midpoint maybe about there. Maybe a little higher. Hard to say exactly, okay? So again, now that I've got those connected, I'm going to go ahead and, got those midpoints, I'm going to go ahead and connect the dots. All right, and this one's a little bit tricky, but I would say that if I could, I didn't do this with my X graph, so I'm not going to be able to do it with my Y graph, but I can say that I could just think about this for a minute as though I were starting here instead of starting all the way back at the origin, right? Starting at t equals 0. And if I do that, it gives me a sense of what the graph looks like. It's a sine graph, right? It's a continuing sine graph. So if I think of this as a sine graph that's just been shifted, then I can at least think of it as a sine graph. And so I'm going to argue here. I want to see, I'll make sure I use the right colors here. My Y graph is some kind of a sine graph, right? We don't yet know other things like amplitude and we might end up having to shift it a little bit, but start with just kind of the most elementary information that you can. And that would be that this looks an awful lot like a sine graph. Okay, so I'm going to start with that. And then let's take a look at what we've added to, can you see the amplitude of this is probably about 1. My drawing skills here are really not good, but it's certainly not more than 1. And since I used using integer values here, I'm just going to say that its amplitude is 1. And also I have a single cycle. Okay, and so then I want to look at what I'm adding to this. And so I can see here I'm adding some value to my red graph to get up to my blue graph. But let's go back to the very beginning and see what we actually added. Starting at t equals 0, it looks like we had to come down a little bit to get from the red graph to the blue graph. So it looks like it's maybe going to be a minus. Okay.
Wait, why is it a minus?
Because if I take this red graph and stretch it out, pull it taut like that, and then add the blue graph on top of it, I'm starting down below it and coming up, right?
Oh, okay.
See that? So that means that this blue graph is, the first thing I do is subtract a value from it. It's essentially making a negative cosine graph here instead of a positive one. Does that make sense?
Yeah, thank you.
Okay. So, right, so my red graph has an amplitude of 1. My overall graph has an amplitude of 2. So that means that what I'm adding or subtracting has an additional amplitude of 1, because these two have to add up to the total amplitude of 2. And then I have to look at the shape of the graph and see how many cycles there are. Okay. So it's kind of a little tricky because I'm starting down here and coming up, and then it feels like a cosine graph to me. I'm not absolutely certain, because they're not. Actually, I think maybe it's a sine. Let me back up a little bit. Let me take some of this extra gray stuff off here. To back up a long way to get to where I wanted to go. I'm looking at this graph here at t equals 0. But when I look at the sine graph that I started here to find, I noticed that if I'm taking this sine graph, this red graph, to be a sine graph, then I'm also maybe going to want to consider starting there to find my the graph that I've had to add to that sine graph. So I'm thinking maybe that's a sine graph. I'm actually hoping that what you're hearing in my voice is some uncertainty, because I'm not absolutely sure. And I think it's important for you to recognize that, you know, there's not real math. I love saying this, real math is messy, right? So at some point, sometimes you just have to sort of take an educated guess and try it out. And if that doesn't work, you can reassess, or you can start tweaking the equations. So if I start there and I look at that as the graph that I've added to the red graph to get the blue graph, or that's the blue graph, then the next cycle of that would be here. And the third cycle, or the next cycle of that, would be here. And note that since I started over a bit, I'm also going to extend my graph over a little bit here as well. And so I'm probably going to get a full sine right there as well. Okay. So I need to go back because I erased this part here. So I'm going to go back to the red graph. Was a sine graph. There was only one cycle of it. We kind of looked at it as starting here. It had an amplitude of 1. And then on top of that, I'm going to add my gray graph, which is also a sine graph. And it looks like we have 1, 2, 3 cycles. But remember also, I said it when we started with it back here, but it's also true here. It's a minus, right? It's going to be a minus. I'll just change that to minus the sine of 3t. All right, so that, I feel like that is a perfectly good way to start trying the equations. So we start by plugging those equations in and see what happens. Let me blow this up a little bit. Can you still see my, there it goes. Okay. I was going to ask if you can still see this, but I can see from the green box around it that that's still what's in view. So you should still be able to see that. My x graph is cosine of t plus 2 cosine of 3t. And my y graph is sine of t minus the sine of 3t. Okay, so let's try that. Okay, well, it's not perfect, but I can see that all the loops are in the right places. Or sorry, all the loops are there. I don't know, they look to me like they're in the right place. They're just not far enough over, or, you know, there's some asymmetry going on here as well, and that's something we need to consider. So, cosine. So one thing that I will try here is the red graph that you can see right now is very symmetrical. And that's a bit of a problem because the blue graph I'm trying to emulate here is not symmetrical. And so one of the observations I want to make back over on the iPad is that you can see there are 2 cosines in this equation and 2 sines in this equation. And that actually suggests to me that there's going to be some symmetry. So one of the things that I'd like to do is to kind of reconsider the graph that I made for y of t and think about it in a slightly different way and see if I can come up with an alternative. I'm going to erase the equation I came up with. And let's just talk about the red graph again from the perspective of, I'm going to redraw it here. If I started the red graph down here at -1 and all the way over here at t equals 0, then I might have something that looks more like this. It's a cosine because I'm starting above or below the point, the 0 there, right? I'm starting below 0. It's a negative cosine because I'm starting below 0 instead of above it. And I still have one cycle. So looking at it again, let's say, well, we want some asymmetry. So maybe it wasn't a sine graph. Maybe it's a cosine graph. Try it and see what happens. Then the next thing to consider, I'm going to go to green here because we've got a whole bunch of colors on the board now. And so there are a lot of gray and orange already, blue and red. So I'm going to switch to a different color altogether. And what I'm going to do now is I'm going to look at this region right here. It's not, they're clearly not together here, but remember that my midpoint that I put in there, I was kind of eyeballing it. So maybe I missed. Maybe it's more like here, right where the blue graph starts, the red graph should come off of there. That's a possible scenario that I hadn't previously considered, right? If that's the case, if that was my smooth graph, I hope nobody's red-green colorblind because that's absolutely horrendous if you are. Let's try changing it to a different color. Chartreuse. There we go. This point right here, or this graph coming up from here, instead of the red graph that you can currently see, that is a possible scenario. And if that's the case, then my blue graph, I'm adding a sine graph to that, right? Because they're starting in the same place. So this may be a sine graph instead of a cosine graph. I still have one, oh, I picked the wrong color there. I wanted orange. 1, 2, 3 cycles. And it has an amplitude of 1 because these two, I didn't write a 1 in there. These two numbers, the amplitudes of the two graphs, have to add up to the total amplitude of the final graph. Okay, so there's another possible scenario. Let's try that. Instead of sine of t plus sine of 3t, we'll try negative cosine of t, and this became a plus. That's much closer. So you can see now the asymmetry, right? All right, so what might I try next? Sine, let's see, cosine 2 and 3 and 1 and 3. It looks a little bit like my amplitude is a little bit too big, but it's too big out here and too small in here. So once I've figured out what here it's too small in the y direction, my red graph isn't quite tall enough, but in the middle it's too tall. So my overall amplitude is correct, 3 and 3 and 2 and 2. I'm just wondering what else I might try here. At this point, you might want to start playing around with things, but keep in mind that the more you change them, oftentimes what will happen is you get farther away from the graph. So changing a plus to a minus, for example, in this case had no effect because sine is an odd function. Cosine's an even function, so my guess is that this will have a different effect. It did have a different effect, not the one I was expecting, but it did have a different effect. So you can start to see I'm actually not getting farther away from the graph that I originally had there. So I'm going to go back to what I had before. But there's no law that says you can't just play around with things like that. What would happen if I made this one positive? Okay, see how that's flipped it around the...
If you tried negative sine t,
instead of the cosine?
Yeah.
Let's try it. Is that the one you meant, Mike? Right
Yeah.
here? Oh, I did not, but look what's happened. I'm back to having symmetry, but I have what WAMAP thinks is the right answer. Now that doesn't mean I have to stick with that answer, but it does mean that I did have a sine here before, so maybe I want to reconsider my X graph. I'm actually pretty confident about my X graph, but if I change this, then I'm going to need to change this one as well. Notice that now I have 2 sines and 2 cosines though. So maybe one thing we should do is try changing one of these to a sine and see what happens. Well, that wasn't it. What about the other one? Can you see why I'm doing that? Why instead of 2 sines and 2 cosines, I want some different combination of those things? Oh, well, there you go. There is no harm in, you know, playing around with things like that. Obviously, got us the right answer, right? What we've done essentially is made a very heavily educated guess with our first attempt and our second attempt. And then we could see that we were close, and what we wanted was that the symmetry needs to be missing. You know, we have some symmetry, but not, what we have is symmetry. I'm not actually sure this is accurate. No, we don't have symmetry this way either. But we want to get rid of the symmetry that we had in the first case. And so that's why I went to not 2 sines and 2 cosines, but one having one of each. You can also get symmetry with, if you have a sine and a cosine and then a sine and a cosine, that will give you symmetry as well. So different kind of symmetry. But you can keep that in mind as you're playing around with it, and you know what kinds of things to change. It's also possible, let's see what happens if I take that negative off. No, now that didn't work either. But you can see that these are the little tiny changes like this can change your graph completely. And we made one change here, and then I made another symmetrical change over here, and that was enough to get us the equation. Okay, so that's number 8. Hi, Anna. I didn't see you come in down there. She's muted like the rest of us, but I see you down there just now. Okay, so that was number 8. Mike, negative sine t plus, there we go. Yeah, so that worked. Did you have that? Did you get that right yourself, Mike? Is that how you need to change that to a negative?
I actually pulled up Desmos and was playing in Desmos a little bit and stumbled upon it.
Okay. Desmos is I mean, you can play around in here, or you can play around in Desmos and then tweak it there and bring it back. It doesn't really matter. Desmos is a great tool. I've never felt the need to use it because I can just play around with the equations in here, and maybe the interface is a little bit, I think you can just hit enter in Desmos and you get, I don't know, maybe it's a little bit easier to play around in. That's fine to do it that way. It's fine to play around in Desmos. GeoGebra is another really good graphing app, and they have a 3D version, which is really useful in Calc 3. So, what was I going to ask you? I wanted to know, when you were playing around with it, Mike, just because you were the one that eventually came up with the correct equation for y, where did you start? What point did you start at?
I started where you started.
Okay.
Yeah.
And you got a sine graph. That's really interesting. Did you go the other way? No, that wouldn't have made a difference. X is 3. I'm just curious about what that's doing. If we start at 0, 3, then sorry, 3, -1. Then x is 3 there. I'll go ahead and use, I'll just use the
This may not
chartreuse.
be what you want to hear, but it's
That's okay.
like rapid iterative experimentation. Is I input different values, and because Desmos is so much quicker, I can try different samples and
Right. That's actually a really good point. I'm curious about, let me see if I can get into Desmos real quick here. And I'll share that.
it's pretty powerful. So I don't know if you know how to do it, but you have to put it in as an ordered pair.
Yeah. Let me see. I thought I was sharing that. What I really want is just the, oh, there it is. All right. Can you see my Desmos?
Yes.
Okay. My green window's not showing up. So if you're playing in Desmos, you have to type this in as cosine. I'm going to put my original one in, cosine t plus 2 cosine of 3t, comma, that's the x coordinate, and that makes sense because that's what parametric equations are, right? What you see here is the x coordinate with t as its own sort of specialized variable, and then the y coordinate is negative cosine. I know this is not what we agreed on, but we want to experiment with it. Negative cosine of t plus sine of 3t. Okay, so there, from here to here is the y coordinate. Okay, and I'll close those parentheses. And then you remember that what we were doing here was saying take different values of t, plug in different values of t starting with 0, and go from 0 then until you get to wherever you want to stop. And you could say maybe pi or 2 pi, and it turns out that 2 pi is what we need for this graph. Okay, and then this is actually something that I have not experimented with, Mike. How do you do the, I mean, I know how to make a variable here. Is that what you did? Just put like an a in here instead?
No, I mean, mine was much more simple. Like you can just, I mean, you can, it changes instantly. So you could just overwrite negative cosine with sine, just write in sine. And it just, you don't even have to press enter or anything. Once it registers it, right? And boom.
So you just play around with it that way?
Yep.
Okay. Yeah, and if you're changing, you're actually changing the functions, then you do need to do that. So you just end up playing around with it that way. The reason I was asking you about making it a variable is because you can also, sometimes you can do things like this, and I don't know if this is maybe not all that helpful. Add a slider, and then you can change the values of a. So you can see exactly at a particular point in time t, what that, let me see if I can slow this down a little bit. At that point in time t 0, for example, where that particle is, where that point is. Okay, so by doing this, by changing our equation to this up here, what we've ended up doing is effectively starting at this point here. Can you see that where the blue dot is there? That's where we're actually starting when we use this equation. So although we started our graph down here, we've tweaked it so that now we're starting up here. I don't care. That doesn't matter. What matters to me is that you understand how this parameter is working. And we are just kind of playing around with it at this point. But that's effectively what's happened is we've moved our starting point. Okay. All right. I hope you found